Chapter 7 is our nomenclature chapter. Nomenclature is a fancy word meaning naming. Our first section is going to be focused on how to name ionic compounds specifically. We have two objectives: write the name from the ionic formula and then write the formula from the name, which is the reverse. So the first thing you'll have to be able to do is identify your compound as ionic. How do we do that? Well, we want to find whether or not there is a metal present in the compound, because ionic compounds are a metal plus a non-metal. For example, sodium oxide is an ionic compound because sodium is on the left side in the metal section. Remember, that's everything on the left side of the staircase is a metal, and oxygen is on the right side in the non-metal section. Remember that non-metals are all on the right side of the staircase. So because this is a metal plus a non-metal, metal plus non-metal, that makes this ionic. And since it's ionic, we can name it according to the rules within this section of notes. Are there any exceptions to this? There's only one exception. If your compound begins with a polyatomic ion, then it's going to follow these rules of naming ionic compounds. We only have one exception in this course, and that's going to be ammonium. Remember, ammonium is NH4 with a +1 charge. It's a polyatomic cation. Polyatomic because it's two or more nonmetals with a charge. And so if you find a compound that has ammonium in it to begin with, for example, ammonium phosphate, for example, if we have ammonium here, then this is considered an ionic compound, and so we will name it according to the ionic rules. So we're going to start with how to write a formula from a name. For example, iron 3 oxide. The formula for that would be Fe2O3. How do I figure out that? Well, two things you should know. First, there's always a cation and an anion present. Remember, the cation is our positively charged ion and the anion is a negatively charged ion. So our cation in this case is iron. Iron has a +3 charge because it's iron 3, so that's Fe +3. Our anion is oxide, which is oxygen with a -2 charge based on the periodic table. And so remember that the cation always has to come first and the anion is always going to come second. And what you need to tell me is, what is the ratio in my formula? How did I know that I need 2 irons and 3 oxygens? We have two scenarios in order to figure out our ratio. The first one is whether or not the charges cancel, you'll get a 1-to-1 ratio. Remember, an example of that would be calcium sulfate. Oops, I guess I should be going from the name. Calcium, I'll change it up a little bit. We'll just do calcium sulfide. Okay? Calcium sulfide, realize that calcium is Ca+2, sulfide is S-2, and because the charges add up to equal 0, they're going to cancel. And because they cancel, it means we need a 1-to-1 ratio in our answer. And so the formula is going to be, because it's a 1-to-1 ratio, I need 1 calcium and 1 sulfur in my final formula. Notice there are no charges on my final answer, and notice there are no subscripts. That's because a 1-to-1 ratio, 1s are understood. We only write 2 or above as our subscript. We can also switch charges in order to get our ratio, which is what we had to do above with iron 3 oxide. So if I could use that same example again, iron 3 oxide, first I need to know what is my cation, what is my anion. The cation's Fe+3, the anion is O-2, and because the charges do not add up to equal 0 this time, we're going to switch them to get the ratio. So the 2 on oxide lets me know I need 2 irons, and the 3 on iron lets me know I need 3 oxygens. So my ratio is 2-to-3. Iron, 2 of them, oxide, 3 of them. And that would be my final ratio. Notice again, there are no charges on the final answer. Sorry, having a glitchy moment with my board. There are no charges on the final answer, and my subscripts are written down low, not up high. A lot of people on occasion will try to write their answer with their numbers up high. This is not the case. You shouldn't do that. Okay, so let's try this out with a few examples. Silver nitrate. My cation for silver is Ag plus 1. My anion for nitrate is NO3 minus 1. Because plus 1 and minus 1 cancel, so in this scenario we will cancel, giving us a 1-to-1 ratio. My final ionic formula is 1 silver and 1 nitrate. Notice that nitrate all stay together. This whole thing is nitrate. On your list, it's a polyatomic ion. We don't move the numbers around in nitrate. So the fact that there's a 3 here, that's part of nitrate. It has to stay where it is. So my final answer is just AgNO3. There are no parentheses because you only need parentheses when you have more than one polyatomic ion. And the second one is going to be an example of that. Ammonium's cation is NH4 plus 1, sulfide is S minus 2. In this case, the charges are going to switch. I need a ratio of 2 ammoniums to 1 sulfide. So I need 2 ammoniums. Ammonium is NH4, and because I need 2 of it, I'm going to have to put it in parentheses. This signifies 2 ammoniums. I only need 1 sulfide, so I'm going to put an S for sulfide. And that's going to be my final ionic formula. You only need parentheses when you need 2 or more polyatomic ions. Sodium is Na plus 1. Dichromate is Cr2O7 minus 2. We're going to switch the charges to get our ratio. So I need 2 sodiums to 1 dichromate. So my formula will be Na, 2 of them, and I only need 1 dichromate, so it will not go in parentheses. I will just write out dichromate in its entirety. Lead 2 hydroxide. Lead is Pb plus 2. Hydroxide is OH minus 1. And because the charges are different, they're going to switch again. I need 1 lead to 2 hydroxides. So my formula is going to be 1 lead. And hydroxide, I need 2 of them. Because it's a polyatomic, it will go in parentheses with a 2 next to it. Last one is copper 2 sulfate. Copper is Cu plus 2. Sulfate is SO4 minus 2. In this case, our charges cancel, so I need a 1-to-1 ratio. So that just means that I need 1 copper and I need 1 sulfate, and sulfate is SO4. No parentheses necessary ever in a 1-to-1 ratio. And remember, the 4 right here belongs to sulfate. This is a unit altogether. That's a polyatomic ion. Keep it intact. In section 1B, we'll look at how to do the reverse. Given the formula, write the ionic compound's name.